In the last segment, we talked about osmosis as a colligative property, and specifically with respect to tonicity. So on the top of page 27 in your lecture notes, I have created a couple of more examples. In this situation, if this is the reference, then this chamber is hypotonic to the reference, and the water will move to the particles. Over time, this chamber will take on water. If this one is the reference, water will move to particles, and over time, this chamber will take on water. It will be the reverse if you switch your reference. The last segment, Lucky 13, will talk about the solid state, and this will be very short because we don't have a whole lot we're going to say about this in this particular unit. The solid state occurs when the neighbors are so tightly packed that they retain shape. And so they have certain properties that are different than the others. They have very, very, very high intermolecular attractions. And because of that, they have very, very high boiling points and very, very high melting points with respect to the other substances that we've looked at. They also form crystals and pack together in very specific ways. And there are whole courses on this, so I'm simply going to give you a visual and think about how you pack groceries in a grocery bag when you go to the store. Your packing is going to be different, for example, when you have boxes of cereal versus when you have cans of fruit, or when you have fresh pineapple versus, say, boxes of microwave popcorn. It's very specific how they pack together, and you have a variety of things that you consider when you do that. Again, crystalline structure is something to be saved for another course. However, there are certain things that we'll say about this. One is that we have something called an ionic solid, and they create something that we call a lattice network. Okay, kind of like Tinker Toys. And so they're held together as something that is very, very, very strong. And they have very high boiling points, very high melting points. They're very hard and they're very brittle. So examples would be NaCl, MgO, CaCO3, your typical ionic substance. Okay? You have what we call covalent networks. Okay, and these are, for example, something like a diamond or something like quartz. All right, and these are very, very, very tightly held together due to the tetrahedron. Remember, your tetrahedron has a very specific structure of 109.5 degrees in every angle. Okay, so your quartz and your diamond are some of the hardest substances known to man on this planet. Molecular solids are things like CH3Cl solid, or perhaps CO2 solid. Molecular meaning they have covalent attractions. Okay, now those are held together by rather weak intermolecular forces that we saw before. Your London dispersion forces, your dipole-dipole forces, and we saw that these are pretty weak. So these tend to be soft and have low melting points and boiling points, and actually they can often be gases at our normal atmospheric conditions, or they don't stay solid for very long. The last are metallic solids, and examples of these are things like copper. And these are metal atoms held together by what we call metallic bonds. So what we have is the metal, 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 and floating on the surface are electrons. Okay? And so what happens is that because those bonds are characterized by electrons floating at the surface, the electrons are flowing and they're highly mobile, these substances are very good at conducting electricity. Okay, so we typically have, for example, copper functioning as wire in our houses. They're malleable and easily shaped. We can take copper, we can take other metals like lead, not that lead is a good conductor, but we can mold them into shape. Okay? Now let's try a couple of examples. Okay, so sodium chloride is ionic, so it's going to be an ionic solid. It will have a very high boiling point and a very high melting point. Diamond is going to be a covalent compound, and hence it's going to have a covalent network. Very, very, very high boiling point, very, very, very high melting point, very strong substance. CO2 is covalent, not a covalent network, so we're going to call that a molecular solid. It's going to have a much lower boiling point and a much lower melting point, and maybe even not even a solid under normal earth conditions. And lastly, we're going to have copper, which is a metal. So it will be an example of a metallic solid, and it will probably be a good conductor of electricity. It's probably going to be malleable and bendable. Okay, so that's going to be the end of Unit 4. You should do all homework, quizzes, Blackboard assignments, any videos, any practice exam, anything that problems, exam, etc. Okay? Specific instructions to be announced, and the Unit 4 exam will be announced as well. Thank you.